Hi, my name is Katherine Jijo. I'm a senior computer science student and AI researcher, and one of the most technically impressive systems I've built is an active learning pipeline that fine-tunes LLMs with minimal labeled data. I co-authored a research paper at Cornell Tech based off this work, and my goal is simple. It's to reduce labeling costs by over 90% while improving model performance in niche high-stake domains like healthcare and finance. It mimics a production-grade ML pipeline with custom-built data ingestion, training entropy-based sampling, and evaluation and visualization all built from scratch. This matters because manual labeling is slow and most companies cannot afford to label 10,000 examples. So I built a system that starts with 10 labeled examples, ranks predictions by entropy, and retrains only the most uncertain ones. Before we look through the code, let's understand how this system can be applied. Let's take the message, urgent notice, last chance to update your personal information. Table 1 is a zero-shot model with no labeled examples, and it has an entropy of 51%. By table 4, we've iterated twice, providing 2 labeled examples, and the entropy drops significantly to 18%. Drop in entropy means the model is becoming more stable and making its predictions without needing thousands of labeled examples, and this allows us to reduce annotation costs and accelerate deployment time. Now let me walk you through the core components of the active learning pipeline I built using BERT and entropy sampling. We start off loading the Amazon review data, simulating real-world active learning setup, which is 5% of labeled data and keeping 95% in an unlabeled pool. In this part of the code, I tokenize the text using Hugging Face's BERT tokenizer to prepare for model training, and I use BERT-based model for multi-sequence classification with 5 custom labels mapped to sentiment. This is where I define training arguments to control logging, batch size, a valve strategy, and enable mixed precision training for speed. This block of code, I created a PyTorch compatible dataset class to pass tokenized data to into the trainer. This is my evaluation code. I use standard classification metrics, accuracy, F1, precision, and recall to evaluate the model after each round. Here is my trainer setup. The trainer handles the training loop for evaluation. Next is how we calculate entropy for uncertainty sampling. So this function calculates entropy, which measures uncertainty. Higher entropy equals more uncertainty, which is better candidates for labeling for the next round. This function right here wraps everything together, returns a sorted data frame of the most uncertain examples to feed into the next training cycle. This is the core of the active learning process. We loop over the entropy rank samples, add 10 new uncertain examples each time, retrain the model, and track the metrics. And here, this code block plots accuracy, precision, and recall over each iteration. As we label more data, entropy drops off and model confidence rises until it levels off. In the end, I run final predictions, output the results into a CSV for future analysis, as well as create a confusion matrix to understand where the model is performing and where it's misclassifying. Code itself outputs a CSV, and as you can see, as we increase from 10 labels to 150, accuracy increases from 10% to 60%. Code also outputs a confusion matrix as well. The system yielded ideal results, entropy drops, and accuracy climbed, and we hit diminishing returns fast, which means you can get high performance with minimal labeling. This became the foundation for a research paper I co-authored. It's on arXiv now. Thank you for watching. This is the kind of AI I love building, scalable, research-backed, and I'm excited to continue exploring my passion for AI throughout the summer research fellow grant.